Hi everyone. So in this geometry series, we are going to learn the problems and solutions of theorem 4. So already we have learned about the theorem 4. Now we'll see the problems and its solutions from theorem 4. Now let's see our first problem. Now you see the show that the bisector of the vertical angle of an isosceles triangle. So this first problem is the bisects the base, and the second problem is the perpendicular to the base. Okay. Now you see the diagram, then you can understand very well. So this A, B, and C. This is a triangle. So and this A and D. This AD is the bisector of the angle. Which angle? This BAC. Okay. So we have to prove that this line, this AD line is bisect this BC line. So this point of this BC line is the midpoint. And another we have to prove this AD line is the perpendicular. This AD line is the perpendicular with this BC line. So this BC line. Okay. So now we see the proof. Now you see this is the diagram. Now we have to prove this ABC is the isosceles triangle. We have to mind in our mind this ABC is the isosceles triangle. So this isosceles triangle means this AB line and this AC line, these two lines are equal, or these two sides of these triangles are equal. Okay. And this AD line is the bisector of the angle BAC angle. Okay. And this D point is the meeting of this BC line. So this line, this BC line. Now we have to prove the first problem is the AD is the bisect of the baseline of BC. So this baseline of the BC, we have to prove this again. This another way you can say this point D is the midpoint of the BC line. Okay. Now you see we have two triangles. Now we have two triangles. This one triangle is the ABD triangle, this triangle, and another triangle is the ACD triangle, this triangle. Okay. So if we prove these two triangles are equal in all respect, then we can prove that this BD line equals to BC line. So let's see our proof. So it is an isosceles triangle. So this AB equals to AC and angle BAD, this angle BAD equals to DAC. Why? Because this AD line is the bisector of this total BAC line. Now you see this AD, this AD line. This AD line is the common line of this two triangle. BAD triangle, another is the CAD triangle. So now we can see These two triangles are equal in all respect. It is from proof from the theorem 4. In all respect means these two triangles, 6 parts. 6 parts are equal. 6 parts means 3 sides and 3 angles. You can say this is the corresponding. This is the important. This corresponding. Now we can say. Now we can say this BD line. This BD line equals to this DC line. Okay. So this AD line is the bisector of baseline of BC, or D is the midpoint of the BC line. Okay. Now you can see we have proved first problem. Now you see the second point or second problem. So this second problem is we have to prove that this AD line is the perpendicular with the base BC line. This perpendicular with this base BC line. So this should be perpendicular or 90 degree or 90 degree. Okay. So let's see the proof. So this triangle ABD equals to triangle ACD in all respect. So all respect means its corresponding angle. So this angle equals to this angle, this angle equals to this angle, this angle equals to this angle. Okay. Now first come to the point. So this ADB angle, this ABD angle equals to this ABD angle, this angle equals to this angle ADC angle. And we know the one straight line angle equals to 180 degree. Okay, so if we can say this ADB plus angle ADC equals to 180 degree, and this angle is called a supplementary angle. So these two angles are equal. So this one angle equals to 90 degree. So we can say this AD line is the perpendicular with the BC line. Okay. Now we can prove that this AD line is perpendicular with the base BC line. So now come to our next problem, and this problem is very interesting problem. So let O be the middle point of a straight line AB, and let OC be the perpendicular to it. Okay, then P is any point in OC. Then prove that the PA equals to PB. If you see the diagram, then you can understand perfectly. Now you see this is the AB line. Okay, and this AB line, this point O is the midpoint. This point is the midpoint of the AB line, and this point is called the point O, and this line is the OC line. Now you can understand, and this OC line is the perpendicular with the AB line. So already said it is the 90 degree, and this angle also 90 degree. It is already said. Then prove that. Which you have to prove that then P is the any point in OC line. So there is any point, this point, this point, this point, there is any point. Okay. Now there is P is the any point on line OC, and we have to prove that PA line equals to PB line. This is the important. So this P is the any point on line OC, and we have to prove that line PA equals to line PB. Now let's see the proof. Now AB line O is the midpoint, already I have said, and OC is the perpendicular with AB, and P any point into the line OC. Now we have to prove that the PA line equals to PB line. And there is a two triangle is made. One triangle is the PAO and another triangle is the PBO. This one triangle is the PAO, another triangle is the PBO. Okay, you can understand. Now you see these two angles are equal. This line is the common line for these two triangles, and this is the point O. This one is the O, and this is the middle point of the AB line. So that this line equals to this line means the OA line equals to OB line. So we can say this two triangle is equal in all respect. Okay, so this PA line equals to, so this line equals to PB line. Is a simple problem. Okay, and it is proved. Now come to the next problem. So normally when we advances the problems, then maybe slight typical problem we will face. So this problem is the assume that four sides of a square are equal. Okay, so these four sides of a square are equal. So these four sides means the AB, BC, CD and DA. And its angle are all right angles. Means BAD, this angle, ABC, this angle, BCD, this angle, and CDA, this angle. These all angles are 90 degrees. Means all angles are equal. This 90 degree means this all angles are equal. Okay, so we have to prove that the diagonal AC, so this diagonal equals to diagonal BD. We have to prove. So let's see the proof. So again, this is a very simple proof. Now you see this ABCD is the square and its all sides are equal and all angles are right angle. So these all angles are equals and all sides are equal. Now we have to find the two triangle, and these two triangles we have to prove it is equal in all respect. So we have to prove that AC equals to BD and this triangle. So this first triangle is the ABD, this triangle, and second triangle is the BCD, this triangle. Okay, and we have to prove this triangle is equal in all respect. Then we can easily prove that BD equals to AC. Now you see AB equals to DC because its all sides are equal. The squares all sides are equal, and this BC line, this is a common line for these two triangles. This is a common line. Okay, now ABC, so this angle equals to this BCD 90 degree. Okay, now we can say this triangle ABC equals to triangle BCD in all respects, means its all six parts are equal. This corresponding six parts are equal for each triangle. So we can easily prove that this AC equals to BD. So this AC line equals to this BD line. So this problems are we can solve solution. Now we can find out the easily solution for this problem. So this problem is said this ABCD is square. This is again is the square, and this LMN are the middle points of A, B, B, C, and C, D. Okay, so this is the our ABCD square, and this AB, this line AB middle point is the L, and BC middle point is the M, and CD line's middle point is the N. Okay, so which we have to prove? The first problem we have to prove is the LM equals to MM. So this one. So this line, this LM equals to this line. And second, we have to prove this AN equals to AM. Actually, this is problem 3. This AN equals to AM. Okay. And we have to again, this is a second problem. This AM equals to DM. AM equals to DM. And the fourth problem we have to prove the BN equals to DN. So let's see the proof. So first we have to prove the LM equals to MN. Now you see this two triangle, this triangle LBM, this triangle, and again this triangle. Which triangle? Triangle MNC. MNC. For this two triangle, we know the angle LBM equals to angle NCM. Okay, and this is the middle point, so BM equals to MC, and again this is the middle point L, so BL equals to CN. Why BL equals to? Now because this is a half of AB equals to half of CD. Okay, so we can see here there is a two sides are equal and two angles are equal. So we can say this triangle LBM equals to triangle MNC in all respect. Okay, so this ML equals to ML. So ML equals to ML. Okay, so now let's see our next problem. So this we have to prove that this AM equals to DM. So again we have to find out the two triangle. So this two triangle is the AMB. So first triangle is the AMB, and second triangle is the CDM. Okay, so if we prove these two triangles are equal in all respect, then we can easily prove this AM equals to MD or DM. Now you see here, this is a 90 degree. Again, this is a 90 degree. This sides and these sides are equal. Again, this M is the middle point. So this BM equals to MC. If I write here this angle ABM equals to angle MCD, and these two sides AB equals to CD and BM equals to MC equals to half of BC. Okay. So it is easily proved. These two triangle AMB equals to triangle CDM are equal in all respects. Means all six parts are equal in corresponding triangle. So these two lines are equal. So this AM equals to DM. So it is very simple. Now see our next problem. We have to prove here that AM equals to AM. So this AM means, so this is the AM and this is the AM. So again we have a two triangle. So this two triangle is the ABM and another triangle is the ADM. So this triangle, first triangle is the ABM and second triangle is the ADM. So you can easily see this AB equals to AD and this angle ABM equals to this angle ADN. Okay. And this line, this BM equals to DN. So again we can easily say this triangle ABM equals to triangle ADN. Actually I have not written in details, but you can easily understand from these two triangles are equals in all respect, so that you can say these two lines, this AM line equals to this AN line. Now come to the our next problem. So this next problem we have to prove this BN equals to DN. Okay. So this BN equals to DM. Sorry, this should be DM. Okay. Now you can see here easily we can find out that the two triangles. We have to prove in this problems all solution we have to find out the two triangle, and this two triangle we have to prove that these two triangles are equal in all respect, so that we can easily prove these problems solutions. So now we have a two triangle. One triangle is the BNC, another triangle is the DMC. Now you see these two angles. Here this angle is actually is a common angle. This common angle is the, so one angle is the NCB. NCB equals to another angle is the DCM. DCM. Okay. And this sides, this side. So BC equals to DC side. And again, this side equals to this sides. D. So which sides? As NC side equals to CM side. So this MC equals to CM. This MC means half of BC equals to half of DC. Okay. Now you can see here, this is one angle is there and two sides are there. Okay. So these two sides are there. So that these two triangles, triangle BNC equals to triangle DMC. Okay. So these two triangles are equal in all respect. So that this BN lines equals to this DM line. Now come to our next problem. And this problem is a slightly tricky. But just I want to say you something. If you understand the theorem 4 is perfectly, then you can understand the all problem solution in this session. Please, my suggestion, please follow my previous video for theorem 4. And if you understand the theorem 4, next, if you follow these problems and its solutions. And if you see its problems and solutions again and again, then you can understand easily. And if you understand the solution, then I think you can one step up for the next theorem. So these all theorems 1 to 59, all theorems is related with the every theorem. Now let's start this problem. So this ABC is an isosceles triangle. Isosceles triangle means these two sides, this AB and AC, these two sides are equal. And this AX, this AX and AY are cut off. And this is the equal parts. This AX equals to AY. Okay. And this BY and CX, these two lines, this BY and this CX lines are joined. And we have to prove that this BY equals to CX. So where is the tricky? Because here the AX and AY, just we have cut in equal distance. Just you see here. Just I have cut by its equal distance. So if we cut is an equal distance, then you can easily understand this Bx equals to Cy. This is the main point. Then you can easily prove that BCX triangle equals to BCY triangle. Okay, just I have given some hints to solve this problem. Okay, if anybody want to solve this problem, then you can take these hints. Now again we can actually make the solution for this problem. Now you can see the solution of this problem. Now this ABC is the triangle and this CX and BY is the line, and we have to prove this BY equals to CX. Now you see here. So angle ABC, this angle ABC equals to angle ACB because it is the isosceles triangle. Now from point A is the same distance. Again, we know already we have proved this. If it is an isosceles triangle, then this angle equals to this angle. We have proved that. So this from point A is the same distance is the x and y is the cut. So that the ax equals to ay. Again I have told you. So required to prove that the by, this by equals to cx. So this is the mistake. I have told you that this should be the cx. So thank you.